Yep. Yeah, I'm speaking from Hyderabad, India, and welcome to ADCx Gather 2025. I'm very excited to present my talk here. And so I will mostly be covering C++ and how you can write just small amounts of code to make music with C++. So just a bit about me. So you probably know me as Xyzzy on the Discord, and I try to keep discussing some stuff related to any of the topics like AI or anything on the Discord channel usually. And these days, I'm mostly trying to build apps for artists. I'm trying to build some games. I'm trying to do some VR apps as well. And so, yep, you can always ping me on Discord if you need anything. So, just to give you a brief idea, so right now, I think we are basically doing uh, neural music, you could say. So, a lot of AI music that is being generated. But if we go back to the start, it's sort of like the exact opposite. We had some sound chips, and in the sound chips, you used to program them via assembly, and you used to ping them instruction by instruction, and it was all 100% deterministic, and there was no way in which you could, have something guesswork there. It's always like 100%. And so from there to DOS and evolution like MIDI, and we right now have the AI thing on us. So why C++? So my main motivation was to kind of explore the low level side of things, and and that's where C++ usually shines. And you have things like an accurate timer. There's no GC, and you have many libraries that you can use, and that's basically where I got started with C++. Now it is a audio development is a kind of a challenging thing. So you can start with just little amounts of code, and that's hopefully what you can get away from my talk. So here's first example. So this is the simplest thing you could perhaps do. I am basically using this library called miniaudio.h, and it's a single header library. So it's very easy to get started in your projects, and you can just simply load a 909 wave. You can load a snare. I've started a small timer, and I'm just increasing the tick count, and then I'm able to play the 4-on-4 kick. And then I'm able to align the snares as well. So this is basically the most simplest thing you could do today, to just make some simple sounds with C++. So when it comes to timing, the time is sort of the most important thing that the CPU does. And right now, when in any you're using Windows or Mac, your operating system is fundamentally managing dozens of applications. And that's the same for your DAW as well. Your DAW is managing dozens of instruments and effects. And at the heart of it is the clock, where you basically measure time with respect to the CPU. Uh, Audio developers typically rely on the uh, timer. So you can think of it like the sound card has a sampling rate of 48,000 samples per second, which roughly translates to 21.33 milliseconds. And your sound card is pushing the audio data at this speed. And this is usually the way your DAW is perhaps tracking time. MIDI hardware devices have their own frequency with which they run. And so usually they go at a BPM, and at a finer level, they again go down to a finer resolution at that, ranging from like 960 to 40, 24. 24 is probably the least common resolution that most hardware devices probably support. And so here is a basic timer. Again, this is if you're coming from the JavaScript world or the Python world, this should be fairly straightforward. My main background was preliminary in those languages, so this is the first thing I got started with. And this is not optimized, and it is, but it still goes a far, still goes far because it is C++ and things are in general fast. So coming to sequencing, we can, if you think of an orchestra, the conductor is effectively like a sequencer. He's kind of triggering each musician saying, okay, start your section and start the flute, start the violin. And when it comes to what the conductor is effectively doing is he's keeping the time. And he is also telling each section to either intensify their instrument or play it more slowly or gently fade out. So in many ways, this is what I mean by sequencing. Now, sound design is another beast altogether. In sound design, you can do many more complicated things. But when it comes to sequencing, it is fairly a straightforward process. But it's easy to get started with. You can think of sequencing in terms of whether it is discrete, so where you're triggering things, whether it is continuous, you're increasing the intensity of an instrument slowly, whether it is periodic, which is sort of like a sine wave, which is operating at a very low frequency, like 20 hertz. Or you can think of a generic sequencer also, which I will show. So coming to MIDI, so you can probably uh, just 10, 20 lines of code, and using the port MIDI library, you can probably easily play a MIDI uh, note. And this is something that you can use to talk to the DAW or the hardware. Coming to generic classes for sequencing. So at, at the very most basic, uh, basic sequencer that you can do is doing a random number generator. As I uh, explained, there's a clock that is running, there's a timer that is running, and this timer continuously sends a tick message at the rate of the BPM, or a much finer resolution than that. And you can program uh, a simple class with a tick method to kind of run things. And random numbers is easy to get started with. And if you're going a bit further, you can probably use a Markov chain. Markov chain is a very, you can think of it like a miniature neural network. And here you have more control because you can control all the weights. And because of this, the neural network is much more easily malleable. And the weights are very visible, and it's just an array of arrays. And you can use a standard C++ library to, you can use standard vector, standard discrete distribution to probably design a simple Markov chain. And now it need not just be a generator that is generating Markov sequences. It can also generate any extra, it can also generate the tick can listen to a network request and generate a new event, for example. When it comes to, speeding things up or slowing things down, the best way to do that is curves. And curves are also very easy to program. If you look at if you look at an easing curve, an ADSR, or an LFO, these are quite easy to get started with. The other, if you've used any hardware instrument, you might have seen there's a small user interface that they have. And these interfaces are quite easy to do. And on Windows, Mac, and Linux, you have this nice library called ADCx UI that can do some of these interfaces. So I've done a drum pad, and I've also done a sequencer. I can demo that in a while. Now, as I said, the timer that I've designed is not optimized. You can, if you're using something like SuperCollider or you're using Chuck, they actually have a virtual threading that they do. And in modern C++, you can use coroutines to perhaps, you know, you can use coroutines to emulate those. And there's some more libraries. So let me quickly show a small demo. Think hopefully, yeah. So I have a small DAW running on the background and I'm interacting with it using MIDI. And so I've designed a small uh, machine pad of sorts. And I'm just going to trigger some samples. So yeah, hopefully this is just sequencing. I'm not doing sound design. I'm just triggering samples here. And these are standard loops that you have. And yeah, so there are many small libraries like these that you can perhaps use in your project. And if you're just using sequencing, just triggering things and drawing curves, these things are easy to get started with. And perhaps if C++ has been a bit scary to you before, hopefully I have showed you that with just a small piece of code, you can probably make interesting things with it. So yeah, I think you can find me at these links. So I think over to you guys. And I'll be available on Discord if you have any doubts.